Let's take a look at the Unit 1 notes in trigonometry. We're looking at the basics of trigonometry here. Here's all your assignments. Section 1.1 to 1.4 is what we're going to focus on first, and then we'll move on to the graphs, which get us moving into 1.5 and so on. So here's the first idea in trigonometry is that you are used to working in degrees. In trigonometry, we're not only going to work in degrees, but we're also going to work in radians. And so when you look at working in radians, you need to know what those are. And so we start with just kind of a general idea of the degree measurement. So you know that this is 0 degrees, starts here. We go up to the top, and this is 90 degrees. You go off to the side, and it's 180 degrees. And down to the bottom is 270 degrees. And then we finish off the circle by going to 360 degrees. And then we can keep going around the circle and adding how many ever degrees we keep going. So if we went another from 360 to another 90, if we went all the way around the circle, and then another fourth, we'd end up at 450 and so on. Okay. Now in radian measures, we're going to measure the same exact places around the circle, except that we're going to start off with 0 radians. And notice that I didn't put the little degree mark, so if there is no degree mark, it's assumed that that's in radians. Okay, so this is 0 radians, and then radians are measured as a multiple of pi. And so this 0 degrees, then if I go halfway around the circle, I actually end up at pi. Well, if I only went a fourth of the way around the circle, I wouldn't be going pi, I'd be going half of pi, which is pi over 2. So up here at the top, at 90 degrees, is pi over 2. 90 degrees and pi over 2 are the same. In fact, to the point where I want to move this so that this is actually right up here on top, so that you know that that goes right up on top. Well, if I went 180 degrees and I went another 90, so I took and I went all the way to pi, and then I added another pi over 2, and I add another pi over 2. This is what it looks like in math terms. I went to pi, and then I added pi over 2. Well, in order to add those together, I have to get a common denominator, so I multiply both top and bottom by 2, so I get 2 pi over 2 plus pi over 2, which is a lazy one in front. I get 3 pi over 2. So if I went all the way to pi, and then I continued, I would end up at 3 pi over 2 if I went another 90 degrees, or if I went another pi over 2. I went 1 pi, which is 2 pi over 2, and then I went another pi, which gets me to 3 pi over 2. These are our 4 basic big places that you need to be able to know, and we'll be adding to those as we continue even in this video. But it's important for you to know the difference between degree measurements and radian measurements. Radian measurements are measurements that are multiples of pi, and degree measurements are individual degrees. So to finish off this radian circle, we had 3 pi over 2. Well, if I went halfway around and it was pi, if I go all the way around, it's going to be 2 pi. And so 0 and 2 pi are in the same place on this circle. Just like 0 and 360 are the same place if I'm talking about in degrees. And so if I have the 2 different measurements, I want to be able to go back and forth between the 2 of them. And that's what we're going to look at here next in converting between degrees and radians. To go from degrees to radians, you're going to multiply by pi radians over the number that is equal to pi, which is 180 degrees. So this is like radians over degrees. So what's going to end up happening is you start off with some degrees. You're going to divide by degrees. So degrees divided by degrees, if you think back to doing unit conversions, you did them mostly in science probably, but if you have degrees divided by degrees, the degrees cancel out, which is going to leave you with only radians. So the radians is going to go on top when you're changing to radians. When you're going from radians to degrees, you're going to multiply by 180 degrees, because that's what you want to turn it into, over pi radians. Okay, and rad is going to stand for radians. So 180 degrees over pi radians. So whatever you're going to change it to goes on top. So then the question is, well, why don't we use like 0 degrees? And the reason why is that we would use 0 degrees and 0 radians, and we'd end up dividing by 0. So that's not going to work. So then why wouldn't we use 360 degrees? Well, you could use 360 degrees on the bottom from multiplying, going from degrees to radians. You could put 360 degrees on the bottom, but then you'd have to put the equivalent on top, which is 2 pi radians. Well, if you put 2 pi and 360 underneath it, you can reduce those to 1 over 180. So there's really no point in doing that. Okay, so we want to use the simplest form that we can. And the simplest form we can is by pi over 180, or 180 over pi. So on your sheet, this circle is called the unit circle. It's something that's going to get filled in. I'm going to give you a separate sheet that will allow you to fill in the actual unit circle. And so all of the information that is on the circle on your notes is on this circle right here. So we have 0 degrees, then it goes to 30 degrees, 45 degrees, and 60 degrees, and 90 degrees. These are key things that you need to start memorizing. I will allow you to use this sheet in the beginning of what we're working on here, but eventually you're going to need to have these things memorized. Okay, and so we go, every single one of these hash marks, or these points on this circle, are important for us. And so here's the degree measurements on the inside. If I keep going from that 90 degree mark to the next one, that's 120, 135, 150, and 180. Keep going, I end up with all of these degree measurements around this circle until I get back to the beginning, which was 360. If I have those same things in radians, I start off again at 0, but then I go up to pi over 6, then pi over 4, and pi over 3, and then I get to pi over 2, which we had already talked about at 90 degrees. It's important for us to realize that's the continuing theme that we have here, is that I'm looking at going 1 pi over 6 for 30 degrees. So if I go 60 degrees, I've actually gone 2 pi's over 6. Okay, 2 sets of 30 degrees. So 2 pi over 6 reduces to 1 pi over 3. And so really that's kind of the same idea. We're counting going by 30 degrees. So if you can remember that, you have only 2 different sections that we're adding on here. We're adding on the 30 degree sections, and we're adding on the 45 degree sections. Okay, so we go 30 degrees, we're going up 30 degrees, that's pi over 6. If we go up 45 degrees, that's pi over 4. Okay, so let's go around the 30 degrees here. If I go up 30 degrees, I'm at pi over 6. Up another 30 degrees, I'm at 60 degrees. So that's 2 pi over 6. If I go up another 30 degrees, I'm now at the 90 degrees. That's 3 pi over 6, or pi over 2. If I go another 30 degrees beyond that, I'm at 4 pi over 6. 4 pi over 6 reduces to 2 pi over 3. If I go another 30 degrees beyond that, I'm at 5 pi over 6. Another 30 degrees beyond that, I'm at 6 pi over 6. Well, 6 pi over 6 reduces to just pi. If I go another 30 degrees, I'm at 7 pi over 6. Another 30 degrees, I'm at 8 pi over 6, which reduces to 4 pi over 3. Another 30 degrees, I'm at 9 pi over 6, which reduces to 3 pi over 2. Another 30 degrees, I'm at 10 pi over 6, reduces to 5 pi over 3. Another pi over 6, I'm at 11 pi over 6, which doesn't reduce. And another 30 degrees, I'm at 12 pi over 6, which reduces to 2 pi. Okay, and so really there's 30 degree increments here. Pi over 6 just continues going up. So if you know that each one of these hash marks at 30 degrees is going up a pi over 6, then that's what you need to remember in order to continue with this problem here. Then the second set that we added on, well, was pi over 4s. Okay, so if I went up 45 degrees, I went up pi over 4. If I go up another 45 degrees, I'm now at 90. which gets me 2 pi's over 4. Well, I can reduce that to pi over 2. Okay, and that's the same thing. If I move on another pi over 4, I'm at 3 pi's over 4. Another pi over 4, I'm at 4 pi's over 4, which is just pi. Another pi over 4, I'm at 5 pi's over 4. Another one, I'm at 6 pi's over 4, which reduces to 3 pi over 2. Another one, I'm at 7 pi over 4. And one more, I'm at 8 pi over 4. 8 pi over 4 reduces to 2 pi. So we really only have 2 different types of increments in here. You need to know that you start at 0, and then you can figure out the rest of the circle by going up by 30 degrees or by 45 degrees. And knowing that 30 degrees is pi over 6, 45 degrees is pi over 4, and then continuing throughout the rest of this circle. The numbers on the outside, they're there, and you can add them to your circle if you wanted to. But we will add them at a later time when we start working with the triangles and trig functions within the unit circle. We're not going to work with them right now. We're just working on the idea of degrees and radians. So when I go back to our notes again, we're converting, doing some radian measures as a multiple of pi, which means I'm turning these angles into radians. And so the rule says, or the formula says, that I'm going to take the angle and I'm going to multiply it by pi over 180. And the pi is in radians, and so I don't need to put any symbol on there. The 180 is degrees, and so the degrees part of this is going to cancel with the degrees part of this. And so I'm doing 0 times pi, which is 0 pi over 180. Well, 0 times pi is 0. 0 divided by 180 is 0. So 0 degrees is 0 in radians. And so we already know that. We talked about that already. 30 degrees, we just got done talking about this one. But we can show it here. When I multiply by pi over 180 degrees, the degrees are going to cancel each other out. And I get 30 pi over 180. Well, 30 pi over 180, the 30 over 180 is going to reduce, and it gives me pi over 6. For C, I'm going to multiply by pi over 180. So if you don't remember what these degree measurements are, you can convert them, degrees, into radians, or vice versa. You can convert the radians into degrees if you needed to as well. So if I do this one, the degrees are going to cancel each other, and I get 45 times pi, 45 times pi, over 180. If I reduce that, 45 over 180 reduces so that I end up with a pi over 4 at 45 degrees. At 60 degrees, I'm going to multiply by pi over 180 degrees. The degrees are going to cancel, and I get 60 over pi, 60 pi over 180. Well, 60 goes into 180 3 times, so I end up with pi over 3. 60 degrees is pi over 3. We just covered that in the last slide as well. 90 degrees, we should know what this one is. This is an important one for us to remember. The degrees are going to cancel. I get 90 pi over 180. 90 over 180 is 1/2. They reduce to give me pi over 2. Okay, so those are all things that we actually could find from that unit circle, and we wouldn't have to technically multiply these out. But 105 degrees is not on that unit circle, or on that circle that we just looked at. And so I need to make sure that I do this properly and multiply by pi over 180 degrees. And the 180 degrees is going to cancel out. So I get 105 pi over 180. And if I go and I reduce that, I actually end up with 7 pi over 12, just reducing the fraction. 240, multiply that by pi over 180 degrees. Degrees are going to cancel, and I get 240 pi over 180. Take 240 and reduce it with 180, and I end up with 4 pi over 3. And then 360, last one, times pi over 180 degrees. Degrees are going to cancel, and I get 360 pi over 180. Well, 360 and 180, 180 goes into 362 times to get my 2 pi. So you can see that all of these conversions that I gave you at the beginning in this unit circle actually can be worked out mathematically using this conversion chart.